Welcome to the virtual sensor and test fair. My name is Robert and I'm from IfTA. Today I want to give you a short overview about our company and our products. IfTA was founded 25 years ago, focusing on the monitoring of dynamic signals in the range from several kilohertz up to 100 kilohertz. The signals mainly come from sensors like microphones, pressure sensors and accelerometers. Here on the table we have a few of our products that you also can find on our homepage. First of all, here on the right hand side you find the Dynago. The Dynago is our small portable device for doing a quick measurement. You can connect the sensors directly to the inputs, so you can measure voltage, current, strain gauges, Q lights, but also sensors that provide a charge as output, because the input card has already an integrated charge amplifier. So this is really for quick measurement. You put the device near to your machine, connect the sensors, connect your laptop by a network cable, start your measurements, see the online data, and you can also of course record data on your laptop and then analyze what's going on in your machine. Our next product is the Dynamomaster here in the middle. This form factor, it's a small case, but we also offer a bigger case. It's for a longer measurement, where you want to monitor a machine over 24 hours, 7 days a week, and over several weeks if you want. It's for unattended monitoring, and it will generate small overview files in order to be able to analyze all the collected data. If we talk about data in this high sampling rates range, then we quickly have something like 500 megabyte within 5 minutes. And so if you keep the system running for several weeks, it will be a lot of data. But we have built into the system certain functionalities in order to allow also to deal with these big data volumes. And the last product I want to present here is this one. It's for cabinet mounting, and we call it the Smart Protect system. It has a real-time processor doing all the analysis of the input signals coming from input cards, and then the results, which for a simple case can be a warning, an alarm, but also more complex values like relations between different amplitudes and so on, will be outputted by a Profibus card to a control system. When talking about our hardware, you actually have to keep in mind that we have a hardware platform. That means we are offering a set of different input cards, from fast input cards for dynamic signals, slow input cards for rating parameters and things like that. But we can also measure temperatures and digital signals, and we even have a specialized card for rotor dynamics that can be used for angle vibrations and torsional vibrations. In the same way, we also offer not only a Profibus card as output card, but also a digital output card or analog output cards in order to communicate with other systems. This is the hardware platform, but of course, today we live in the age of digitalization, so software is actually what makes the difference. So let's talk a bit about the software. The first step where we have put a lot of effort in is here in the DSP. It runs a firmware called the Signal Miner program, and you can configure it to do whatever analysis you want, and then it will do, when it is running, a real-time analysis of the signals, and will also put the results in real time to the outputs in order to protect your machinery. Here in the Dynamomaster we have an integrated PC for recording the data and providing an online stream of the measured data. This software is called the Data Hub software. It collects all the data, it stores it on a hard disk and distributes it to the network. And it also generates smart compact overview files in order to get a quick overview over larger time ranges. But the most important software that you will deal most of the time with is actually our software for analyzing data, online and offline, and it is called TrendViewer. And TrendViewer is the software that I will present you now in a short demo. So let's switch to a screencast. Welcome back, and now I will give you a demo of TrendViewer. So let's share my screen. This is how TrendViewer looks like if you start it for the first time. You get a document with empty plots here, a data source explorer with no data sources loaded, and an empty plot editor, plot property editor. So let's open a file. This is a sound recorded with a Reiki tube and a microphone. So if I unfold the node here, I can see the different signals which are available in this file. The raw data from the sensor, frequency spectra, and derived signals. So let's pick the raw data, drag and drop it to the empty plot, and select the trend plot, click on Create Plot, and now we see what the sensor has seen. Let's zoom in a bit into this area. Okay, here and here we have higher amplitudes, so an oscillation. Let's zoom in more detail. Can also use my mouse wheel to zoom in or shift the signal a bit. Let's pick the frequency spectrum now and check how the signal was looking in the frequency domain. So I drop the frequency spectra here, and I choose intensity plot. This is basically a waterfall plot in 2D. Click on Create Plot. The first moment I don't see anything, so I must adjust the scaling of the amplitude here by selecting automatic scaling. Okay, now I see here when the amplitude was going up, a certain frequency was excited. Let's pick this frequency spectra again, drop it to the bottom here, and select spectrum array plot. Yeah, okay. It tells me first select the point in time where you want to see the spectrum. So let's do it. Let's go to the time axis and select a point in time. And I see frequency spectra, hertz, amplitude for this point in time. Oh, it would be nice to see a peak marker here. Well, easy. We click into the plot and increase the number of peaks that should be displayed. Okay, the frequency peak was at 430 Hertz with an amplitude of 301 Pascal. Okay, let's have another page. Let's say have one with 2 plots. Okay, create it. And select, for example, the amplitude as a trend plot. I click on Create Plot. And I see the amplitude here, but again, let's do automatic scaling. And you can see how the amplitude was going up and down. And we can have those pages side by side if you want. Very easy drag and drop operation. We can check what was the high peak we saw here. Okay, this was just this short spike here. Of course, we can also have these signals in a list plot by selecting list plot here. And then we see the values of the signals at this point in time of the cursor. And as you see here, we allow also a second cursor. So I can activate a second cursor and place it, for example, here. And then I see the values of the second cursor and quickly can compare 2 points in time. If you want to have more, that's also possible. You can edit the document layout. You can run calculations on data sources and filters. Yeah, there is a lot to find in TrendViewer. And yeah, If you want to find more resources, look onto our homepage. And thank you for listening. Goodbye.